Hi, in this video I will talk a little bit about the post-processing effects and how they work in conjunction with the GPU instance or Unity asset. This will be more of a performance showcase video. I will show the FPS counts here rather than a tutorial. But I will also be showing you how to add the post-processing stack to your GPU instance or scenes. So I've already downloaded the GPU instance or asset to this project. I will also be using the code stages advanced FPS counter here. And I've already also downloaded the post-processing stack to this project. If you'd like to know how to download this, you have to go to the asset store to download to search for this post-processing stack here, and you can download it by importing it. It's a free asset. I'm not using the post-processing stack version 2 here because it's still in the preview stage, and I believe most of the people will be using the older version here. So the scene that you see here comes with the GPU instancer demos, and you can find it under the demos folder here under prefab instancing. The only addition I've made here is to add the FPS counter to show you the FPS counts, and I've adjusted the asteroid counts here to 100,000 from 50,000 in the demo. If I run the scene now without the post-processing effects, it will take some time to generate the 100,000 asteroids around this planet here. But when Unity calculates these, I will just run around a bit. You see 100,000 asteroids here, and the FPS count shows me 150 to 160 sort of FPS here. More at the points that the frustum culling is happening. Yeah, more likely 180 average it seems. So I'm also running this with an NVIDIA GeForce 1060 graphics card. Now I'll go back and let's set the post-processing stack. You have to add it to the camera. The camera rig here has a game object with a main camera on it, and all you have to do is to add post-processing behavior here. And there is this post-processing behavior supplied with this demo, and you can just drag and drop it here. And if I take a look at this, we have anti-aliasing with extreme quality, ambient occlusion, depth of field. You will notice the graphics are being affected by this in the editor as well. But let's run this game now. Again, let's wait for the 100,000 asteroids to be generated around this planet here, which takes a little bit of time. And when it's done, you will see that the FPS is around 140 to 150 right now, with 100,000 asteroids and physics applied on them. Again, if I go to the places where the frustum culling happens, you will see a bigger number here. But on average, you will see the post-processing stack is not changing that much of the GPU instance performance for this scene. You can see here from the info script that we have three prefab counts, prototype counts, and 100,000 asteroids distributed around this planet. And this table number seems to be 160 to 170 here. Okay, that should be all that I have to say for this. Maybe I should also say that I'm using the post-processing stack from the asset store here instead of the new post-processing stack version 2. As I said, this is still in preview, but the performance numbers should be the same with both of them since they share a similar code here. Also, I should say that this provided behavior wouldn't work with the version 2 of the stack, but there's nothing exceptionally interesting about this. All we did was to add a color grading that we thought would look better with the scene. And given the scene is only for providing performance showcases, you can always make your post-processing version 2 behavior for this and copy the, if you like, copy the values from this to the other one. Thank you for watching.